Okay, here we go. Practice test number 1. When you see an equation in slope-intercept form like this one is, the number that's by itself is the y-intercept. So we go to the y-axis and we put a point, we put a dot on 4. And then the number in front of the x is the slope. And it's really nice when the slope is a fraction because the top, of course, tells us to rise and the bottom tells us to run. So here we go. We start from the point that we just put, this point on 4, and we go up 2, we rise up 2, and we run 1, 2, 3. There's our second point, and 2 points make a line. And this question also asks for the y-intercept, and we're going to write the y-intercept as 0, 4. This next one is also in slope-intercept form, but we don't see a b right here. We don't see, normally we're y equals mx plus b, where m is the slope and b is the y-intercept. But in this case, we don't see a y-intercept. So if we don't see it, it's 0. We could actually write right here, y equals 3/5 x plus 0. So the y-intercept would be at 0. We put the point right here. Then we go back to our slope, which is also a fraction, and that's really nice because it gives us our rise, which is up 1, 2, 3, and our run 1, 2, 3, 4, 5. You probably have noticed that we always run to the right. We rise or fall, but we run to the right. And so our slope we're going to put here is 3/5. This next one is also in y equals mx plus b form, but we notice that there's nothing in front of the x. So we wonder what the slope is. The slope is going to be 1 because if we rewrote this problem, it's a y equals 1x plus 6. So our slope is 1. Please don't make the mistake of not seeing a slope and thinking it's 0. Just like we talked about in class, we could say this is an x or this is 1x, right? There's one of the, it's just 1x, so we could write it as 1x. So our slope is 1, our y-intercept is 6. So we're going to put the dot on the 6, and our slope is 1, so that's up 1 over 1, up 1 over 1. You can put as many dots as you want. You only really need 2. Please remember to draw a line through it and include the arrows. Once again, if our slope, like this one, is just a 1, and you want to remind yourself to run as well, you put a 1 underneath it. So the 1, we'd rise up 1, and we would run 1. Okay, number 4, a lot is missing. First of all, there's not even a y. There's an x equals -2. So let's stop here for a second. There are steps to graph this. If you see x equals -2, step 1 is you go to the x-axis, you find -2, and you put a dot on it. The way we taught it in class is that if we had a y equals -2, or y equals anything, our arms are going to be outstretched. Why does a y equal 4 look like this? Can you imagine me putting my arms out? I am right now, but you just can't see it. So any line that has y equals, let's say it's a 4, is going to be this way. You're going to have your dot on 4, and the line is horizontal. So the opposite is true of the x. Once you put in the number, and you put the dot on the x-axis, you're going to draw a line straight up and down. That's x equals -2. And when you think about it, every single point on this line, like this point is -2, 0. This point is -2, 3. This point's -2, 8, right? No matter what point you pick on this line, x is always going to be equal to -2. Because to get to this line, you've got to go 2 over from the origin. So let's look at what they're asking us. They're asking us for the slope. It is undefined. Any vertical line has an undefined slope. Asks me for my x-intercept. Well, this is the x-axis. This is where the line is intersecting it. So our x-intercept is negative 2, 0. It asks me for my y-intercept, and I'm looking at my y-axis right here. Let me get black. Here's my y-axis right here. Do you see the blue line crossing over this y-axis anywhere? No, neither do I. So there is not. So I'm just going to say there's none. There is not. You can say not one, but none is good. Okay. The next one, there we go. We've got the y equals 5. 2 steps. The first step is, see how it says y equals 5? That means go to the y-axis, find the 5, put your circle on it, and we can either memorize that when we have y equals a number, it's always a horizontal line through that number. You can memorize that. Or you could rewrite, instead of y equals 5, you could rewrite it as y equals 0x plus 5. And then that reminds you, oh, that's right, it's a slope of 0, so the line is flat. So our slope is 0. It definitely doesn't hit the x-axis, so there's not an x-intercept, and the y-intercept occurs at 5, 0, 5. It's also interesting to note that every single point on this line, let's see, like this point right here, you get to this point by going to 5, and the name of this point is, I'm sorry, yeah, that's 2, 5. The name of this point is 5, 5. This point is negative 3, 5. If you look at all these points on this line, you'll notice that all of them have y equals 5. That's why this line is y equals 5, because every single point on it has a y that is equal to 5. So I just gave you a couple different ways to understand that. As long as one of them works for you, is good. All right, let's look at the next one. It's plainly in slope-intercept form, and so we're going to go back to, when I say slope-intercept form, I mean y equals mx plus b form. It's called slope-intercept because it gives you both the slope and the intercept. So we're going to look at the y-intercept first. I'm going to find the y-axis and put a negative 3 on the y-axis. And then we're going to, let's go ahead and write that down. Our y-intercept is 0, negative 3. This one should say slope. Our slope is negative 4. Once again, a lot of people like to put that 1 underneath when they're given a whole number slope, because then it reminds them to run. So we go from our y-intercept point and we go down 1, 2, 3, 4, and we run over 1 to the right. There are our 2 points. There we go. Okay, this next one, teachers can teach this differently. I have taught it that we are going to distribute and then gather the like terms so that we can end up with a slope-intercept form. So here we go. I'm going to write the y equals. I'm going to distribute. 3 times x is 3x. 3 times negative 5 is negative 15. And then I stop. I don't distribute anymore. I just take the plus 1 and bring it down. Then I'm going to add my like terms. So I'll get y equals 3x minus 14. Now, can you see this is slope-intercept form? Because that's my slope and that's my y-intercept. So now we know how to graph it. Yes, it's a bummer. The graph that I gave you does not go down to negative 14. So what we want to do is extend it a bit. And if this happens to you on the test, feel free to extend. So we'll have negative 11, negative 12, negative 13, and negative 14. So that's going to be my y-intercept, and my slope is up 3, 1, 2, 3 over 1. I'm going to do that one more time so I can actually get up to the graph. 1, 2, 3 over 1. Then I'm going to connect my dots, and there's my line. Not a perfect line, but I don't have a ruler. Okay, so let's see what the next one is. The next one's the same thing. We are going to distribute. So we will go ahead, write the y equals. We're going to distribute. 2 times x is 2x. 2 times 6 is 12. So then we're going to combine our like terms. We're going to rewrite y equals 2x. And we'll combine 12 minus 8 is 4. So once again, now we have it in slope-intercept form. That's my slope. That's my y-intercept. All right. Let's see. So if my y-intercept is 4, oh, I forgot to write that down on the other one, didn't I? So my y-intercept is 4, my slope is 2. We're going to go to the y-axis and find the 4. We'll put a dot there. And then my slope, if I want to put 2 over 1, that reminds me I'm going to go up 2 from my y-intercept over 1. There's my second point. Voila, we are done. Okay, now these look different. When you see x and y on the same side of the equation, that's new. So when you look over here, it's like, oh, y is by itself, y is by itself, y is by itself. Oh, y is by itself. Okay, there's an x there. There's no y. Y is by itself, y is by itself. Okay, all the things we've done so far, y has been by itself. So we've learned that when we have this, where x and y are on the same side, instead of trying to find the y-intercept and find the slope, we find both the y-intercept and the x-intercept. And the way I taught it in class, I know some of you already used a shortcut, but the way I taught it in class is this. If I go ahead and set x equal to 0, that means I'm going to go ahead and be able to find the y-intercept. Because watch what happens if we plug 0 in for x. It goes away. 2 times 0 is 0. And then all we have left to do to solve is divide both sides by -3. And so I'll get y equals -8. So I go to the y-axis, I find -8, and there's my dot. Once again, as I explained in class, on the y-axis, x is always equal to 0. So when you set x equal to 0, you're going to find the point on the y-axis. And so, all right, we'll put the y-intercept. This is nice. All right. Then we're going to find the x-intercept. So the first time we put in 0 for x, this time we're going to put in 0 for y. So we're going to rewrite the whole equation, but instead of y, we're going to put 0. That means it's gone. All that's left is the 2x equals 24. And to solve for x, to see what your x-intercept is, you're going to get x equals 12. Whoops, once again, we're going to have to extend this graph. If x equals 12, here's the x-axis, and I only have up to 10, I'm going to extend it 11, 12, and there's my x-intercept. So then we're going to connect these two dots. I know this asks for the slope in the x-intercept. This should say, I'm sorry, the slope in the y-intercept. This should say x-intercept, and that's going to be 12, 0. So if you guys can just remember that when you see the x and the y on the same side, we're going to have to do this plugging into 0. Another way to look at it, some people just do the cover-up method. So they might just, with their hand, cover up the 2x and go, okay, -3 times what equals 24? Oh, -8. And that's how they get the y-intercept. And then they do the same thing, and they just take their hand and they cover up the -3y, and they go, oh, look what I have, 2x equals 24. So 2 times what equals 24? 2 times 12, so x is 12. Basically, the cover-up method is, not basically, all the way, it is the same thing as the method that I'm showing you. It's just that the method I'm showing you has a lot more steps so you can make sure that you don't make any mistakes. Feel free to use cover-up method, but just please be careful with it. Same thing here, we notice x and y are on the same side of the equal sign. So we've got to go ahead and start plugging in zeros to find the intercepts. If I plug in a 0 for x, then -2 times 0 is 0, gone. So all I have left is 6y equals 12. Divide both sides by 6. So y equals 2. That means go to the y-axis and find the 2 and put your dot there. Now we need to do the opposite. We need to go ahead and put in 0 in when we see y, and that's going to give us our other answer. So when we plug 0 in for y, 6 times 0 is 0. It's gone. So then we just have -2x equals 12. We're going to divide both sides by -2. So we get x equals -6. That means go to the x-axis, find the -6, put the dot. Voila, we have 2 dots. 2 dots make a line, connect them, and we're done. It asks for y-intercept. Our y-intercept is 0, 2. I don't believe this really should say slope. I believe it should say x-intercept. So the x-intercept is negative 6, 0. And if it said slope, we certainly could do it. We could start at this point and say we go up 2 over 1, 2, 3, 4, 5, 6. So it could be 2 over 6, or you could see actually it is up 1 over 1, 2, 3, up 1 over 1, 2, 3. So 2 over 6 is the same thing as 1 over 3. 1 over 3 is just simplified a bit more. Okay, on to context. Your parents deposit $120 into an account for your morning coffee. You get a frozen mocha each morning that costs $6. Oh, I love frozen mochas. I had to give those up a while ago. The equation 6x plus y equals 120 represents the amount of money y in your coffee account on any given day x. So the first thing we want to notice is that they gave us what we should label my y-axis, amount of money. So we'll write amount of money. You could even just write money for short. That'd be fine. And then it also told us that on any given day is x. Well, I'm not going to write on any given day. I'm just going to write day. So we know when looking at these numbers, like this is, okay, 0 day, before days began, 2 days, 4 days, 6 days, 8 days. When we look at this, we notice the x-axis is going up by 2, so that's interesting. And then when we look at money, we know that 20 means $20, $40, $40, $60. And we also notice the y-axis is going up by tens, right? That's 10, 20, 30, 40, 50, 60. So this is the first time since we've been graphing this year that we're looking at a graph that has the x's going up by 2's instead of by 1's, and a y going up by 10's instead of by 1's. So you'll notice that in context problems, we usually have graphs like this. Otherwise, it's just not reasonable to graph on a graph that just goes up by 1's. So label each axis, check, we got that done. Okay, the y-intercept, let's stop for a second. We see the equation right here. We know how to get the y-intercept, we just practiced it. So that means we put a 0 in for x, and we solve for y. So 6 times 0, gone at 0. And so it tells us y equals 120. So we go to the y-axis, we find 120, and we put a dot. That's our y-intercept. That's going to be 0, 120. We'll come back to what does the y-intercept mean in just a second. Let's go ahead and get the x-intercept in. We're going to use the same equation. This time we're going to plug in 0 for y. So we'll go ahead, plug in 0 when we see y. 0, 0, it's gone. So we have 6x equals 120. Divide both sides by 6, so x is 20. That means go to the x-axis, find the 20, put a dot, and let's see if we connect these two, the y-intercept and the x-intercept. Not a bad line. It's interesting. So it's decreasing. It's going down as the days are moving forward. The money's going down. So let's go back and talk about what does the y-intercept mean? What does it mean to say that this 120 is the y-intercept? In this problem, and in every context problem, the y-intercept represents the initial something, or in the beginning, at the start, before time began. Because when you think about the y-intercept happens when x is 0. So if my x-axis is days, and there's 0 days, well, that means in the beginning, or initially, or before time. So what we'll want to do here is, this is initial. That's always a good word to use. This is the initial amount in my account. I'm going to say my account because the problem says, I don't know why I keep using green. I could probably switch it up here. Okay, so that's the initial amount in my account because it says it's my parents, right, or your parents. Okay, so when you write, you could have written, in the beginning, I had 120 in my account. At the start, I had 120 in my account. So any of those words, is going to work for the y-intercept. Okay, let's think about the x-intercept. We graph the x-intercept as 20, 0. And the x-intercept, we notice something, just like the y-intercept, the x is 0. Well, the x-intercept, the y is 0. We get down here, and this says basically 20 days, and $0. That's what this means. It means on the 20th day, we ran out of money. So on the 20th day, you could even put no money. I ran out of money. A lot of different ways to say this, but basically you want to, when you see something that's on the test, you want to describe the day and what happened. So, just like we did with looking at the y-intercept, on the 0th day, so before time began or in the beginning, we had $120. On the 20th day, we had $0. All right. Wait, did I get all of that? Let me make sure. Yep. Okay, so let's look at this. You want to join a music service. Dotafy's cost model is y equals 5x plus 120, and Tandora's cost model is y equals 10x plus 20. Obviously, these are made up. For both models, x is the number of months. Isn't that so nice that they give that to us? So I'm going to go to the x-axis, and I'm going to write months. And it says y is the amount of money. So we're just going to go ahead and put the y-axis is the amount of money. Okay, so good. Label both axes. Check, we did that. All right, now we're going to need to graph. And so the nice thing is they give us these graphs. Just checking on the time. They give us these graphs in y equals mx plus b form. So 120 is my y-intercept, so I'll find 120. And then the slope is 5. So if we notice, if we go up, we're going up by tens. So I'm going to have to figure out how to go up by 5s. So basically, I'm going to start at 120, and I'm going to go up a very half, and then I'll go over 1. So it's kind of crazy because on the y-axis, we're just going up a teeny bit to represent 5, but then we're hopping over on the x-axis a lot, and that represents 1. All right, so then we're going to hop up another half again and over 1, up another half again, over 1, up another half. Okay, I think we did it enough. And we'll go ahead and connect it. And then when we look at Tandora's, which I'll go ahead and put in a different color, our y-intercept is 20, but our slope is 10. So that means we're going to jump up all the way up to 1, over 1, up 1, over 1, up. It's really up 10 over 1, but you know what I mean. I'm jumping up to the next line. Okay, and if we draw, eventually I think they're going to, well, all right, I hooped it a little bit. It says, what does each y-intercept mean? Once again, initial is a really good word when you're talking about y-intercept. And it's really our initial cost. Initial cost meaning that even before your first month's payments due, just to join Dotafy, it's going to cost you $120 initially. Just to join Tandora's, it's going to cost you $20 initially. So our y-intercept is the initial cost. So which service has a steeper line? Definitely this second one, this Tandora's, has a steeper line. We can see, even if I didn't curve it, that it is, there we go, it is going up steeper. So Tandora's has a steeper line. You could have also told that because steepness is decided by the slope, and 10 is a steeper slope than 5. You could just look at the equations. What does this mean? Basically that the price is increasing at a faster rate. So write something like that. Price increases, or price goes up quickly, more quickly. Price increases at a faster rate. Okay, how much would you have to spend? How much would you have spent with each music service after 12 months? Basically, all we're going to do, we'll write Dotafy's, we'll write the equation. The equation is 5x plus 120. And since months, those are the x, right? The x axis represents all those numbers. It represents months. When they're saying 12 months, that means we're going to take the 12 and we're going to plug it into x. And that will give us what? 5 times 12 plus 120. So that's going to be 1060 plus 120 is 180. And then if we do Tandora's, it's 10x plus 20. So we're going to plug in the 12 there. Okay, and there you go. All right, so the test is only going to have 2 context problems. I know you see an additional 2 problems, 13 and 14 on the back, but this tutorial is long enough. So I'm hoping that you can do 13 and 14 on your own and then come and check with me to see if you're right. I have the answer key. In fact, I'll post the answer key on our blog as well. So check out the blog if you want to know the answers to the back. And thank you for joining me. Good luck studying for the test, and I'll see you in class.